I'm Gary. I'm one of the design specialists here at Jacobs Hall, and this is our OMAX Waterjet cutter. And what you can use this for is to cut any two-dimensional shape out of plate or sheet material. It is a 3-axis CNC machine, which means the nozzle, the waterjet nozzle, can move in the X and Y directions. The nozzle also moves up and down in the Z direction, but that's just to adjust it for the proper height for cutting. You lay your material on these steel slats here over this giant tank of water. In this box is a giant water pump that pumps water up to 50,000 psi of pressure. That high pressured water comes through this stainless steel tubing right here and then exits the nozzle. And right before it exits the nozzle, it mixes with a garnet, a very hard crushed rock or sand type material, and then shoots the water jet nozzle. Because of that high pressure water and garnet mix, this machine can cut through pretty much anything up to 6 inches thick. It can even cut through you. And for that reason, if this machine were to ever cut you, there is a special card we need to send with you to the hospital so they know how to treat you. So an injury with this machine, losing your limbs, probably not even the worst part of the injury, because that high pressured water is going to force that garnet up into your bloodstream, and that's probably what's going to kill you. Okay, so while the machine is running, just pretend that these splash guards go up forever. Do not enter any body part into this area. Okay, the cutting area of the OMAX Waterjet cutter is actually 26 inches by 26 inches, and that's how the machine got the creative name of OMAX 2626. But because there is an alignment bracket in here, and because of the way that you need to clamp your material into the machine, don't count on getting a cutting area larger than 24 inches by 24 inches. So don't design anything that won't fit into a 24-inch square. When you come in to use the waterjet cutter, it'll be during the open metal shop hours, and there should be a design specialist in here who will be responsible for turning the machine on and turning the machine off at the end of the metal shop hours. But just so that you're familiar with all the controls, I'm going to show you the turn on process. That way you know which controls you're allowed to manipulate and which ones you need to stay away from. So to turn on the OMAX Waterjet cutter, first thing we do is turn this big red knob till the arrow is pointing straight up. I usually wait till I hear that fan sound, and then I push the green button on top, which turns on the pump driver. Once that's on, I can twist this knob up here, which turns on power to the PC, which runs the machine. Okay, and then last I go to the back, turn on the compressed air, and then turn on the water. Okay, all right, now the machine is fully on. So let's go back to the pump driver section up here. Don't mess with any of the controls on the pump driver, or else you'll change the speed of the pump, which will affect the pressure of the water, which will affect the quality of everybody's cuts. There's an e-stop button down here. There's also an e-stop button up top. The only control you really need to operate down here is this charge pump switch. Normally it's in the 0 position. Right before you're ready to cut, you need to twist this till it's in the 1 position. You'll hear this, the buzzing sound of the charge pump. That allows the high pressure pump to operate, okay? So don't turn that on until right before you're ready to cut. As soon as your cut is over, turn that switch off. Okay, so that will maximize the safety of the machine. Up here, this is a computer monitor. There's a keyboard and a mouse that operate the PC in here. Like I said, this is a secondary e-stop button powered to the PC. This is a reset and override switch. Don't mess with that. This is a pause button, which has the same effect as taking your mouse, moving the cursor over the pause button in the software, and then left clicking. Okay. It's just a much quicker way to stop the machine just by punching this button or pressing this button. And if the machine were to ever do anything bad, make a weird sound, you know it's going to crash into something, we want you to try to hit this pause button before hitting either of the e-stop buttons. because the e-stop buttons will shut off electricity to the entire machine. The machine will halt, but in order to move the machine again, we need to turn it off, turn it back on, wait for it to start up, turn on the PC, wait for that to boot up, restart the software, wait for that to load, and then we can move the machine again. It's just a much quicker recovery from just hitting the pause button. And then the last control here is this lever, which operates an air valve that allows us to raise and lower the level of the water in the tank. We want to be cutting with the nozzle underwater, so that will reduce the amount of water that's sprayed about and reduces the amount of noise that's generated during the cuts. First thing you're going to have to do is log in using your CalNet ID and passphrase. In order to use the Waterjet cutter, there's two pieces of software you need to get familiar with. That's OMAX Layout and OMAX Make. In OMAX Layout, you can actually design your entire part or import your part from another CAD tool. OMAX Layout will generate the toolpath to make your cut. And then OMAX Make will actually take that toolpath file and then control the machine to actually cut your part. Okay? Both pieces of software are on the design kiosk computers up in 110 and 120 Jacobs. So I recommend that you run your designs through the design kiosks in 110 and 120 Jacobs before coming down here to the metal shop, because in order to use this machine, you need to have a reservation, and you don't want to be using up all of your reservation time playing around with your file and not have enough time to actually cut your part. You can do everything upstairs that you can do down here except cut your part. You can even run through a simulation where the software will test out your toolpath file. When you start up layout, hopefully you'll get a square grid. Each line represents an inch. So this represents a 24-inch by 24-inch grid to make sure that whatever you're designing or want to cut will actually fit on the machine. May not fit on the material you have, but at least it'll fit in the machine. There are a bunch of buttons to control different aspects. It has all the normal drawing tools like drawing a box, drawing a circle, drawing a line. It has some special tools in here. And if you notice, some of the buttons have a little red triangle in the upper right corner. Okay, that means that those controls have more options to them. So if you were to left click on the button, you would just get the default function like line. But if I right click on it, it brings up a menu. Now I can do a single line, which is the default, a double line, or a continuous line. Something as simple as a circle, right? There's a whole bunch of different ways to draw a circle. Okay, so get used to right clicking the boxes, just that way you'll see what all the options are. So if you right click on shapes, there's a kind of a neat tool down here. You go to gear and rack or sprocket generator, and you can just put in whether you want a spur gear, an internal gear, a gear rack, or a roller chain sprocket. Then just change some of the parameters and it will automatically generate that shape for you and then insert it into your design. But what you'll probably do most often is design the part that you want to cut in some sort of CAD tool, in SolidWorks, Inventor, or Fusion 360. And what you can do is save the shape or the face of that part as a DXF file and then bring that into layout. Okay? And the way we do that, under File, don't do Open, don't do Insert, use Import from other CAD. And then you can just browse to wherever your DXF file is. It will import it and then make its best guess as to whether it's inches or millimeters. Just say OK. First thing you want to do is make sure it's about the right size. Okay, so I know that this logo is about 3 inches tall, and I just count the grid lines, 1, 2, 3. Yeah, it's about 3 inches tall. Okay. Now, if you were to import your part and the grid ends up being about this big, and your part ends up being about this big, that means you probably designed it in millimeters, and the OMAX software is expecting it in inches. There's a simple way to correct that. If you right-click on size, you can go down to either shrink inches to millimeters or grow millimeters to inches. So we'll automatically do the conversion to or from metric. I know that this is about the right size. Now the first thing I want to do is run it through the clean tool, which is over here on the right side. And what that does is it looks for common drawing errors that will cause a problem for the software later on. Because the way the software is going to work is it's going to come from the outside looking in and look for the first closed form that it finds and say, oh, this must be the perimeter or the shape of the part. So I'm going to cut to the outside of this line. Then it's going to move inwards, find more closed forms and say, oh, these must be internal cuts. I'm going to cut to the inside of those lines. Okay. Now, if there weren't completely closed forms, it wouldn't know which is the inside, which is the outside. It may choose incorrectly and your part may come out the wrong size. Visually, this may look like a completely cuttable design, but I know for a fact there are some tiny gaps in there that will cause that sort of a problem. So we're just going to run it through the clean tool. It shows you a list of all the things that it's going to check for. The only thing you may want to uncheck is this last one where it says remove unclosed paths within the tolerance of. You may want to uncheck that if you purposely did have an unclosed path. So say just a single line that didn't come back onto itself just to partially divide two parts or whatever you want to do. So once you decide what you want to check, just click on Start. What it does is shows you all the things it's going to check and all the things that it found. So in this design, it found 3 unnecessary dots that it removed and 8 gaps that it identified and closed. Now, I've never checked it, but I'm assuming that it just closes those gaps by drawing a straight line between the 2 endpoints. Okay, and because those gaps were too small for us to even see on the screen, it's not going to affect the shape of the part at all. All right, so now we have a nice clean part. Next thing we want to do is put in our lead-ins and lead-outs and draw the toolpath. Now, the reason for the lead-ins and the lead-outs is that every time the water jet starts up and then cuts through the solid material, create a hole, that's called a pierce. Every time it's pierce happens, the water jet's coming down into solid material, partially eating it away, turning around at the bottom of that hole, coming back up and then out. So by the time the pierce is done, you end up with a hole that's bigger in diameter than the water jet itself. So you wouldn't want to pierce up against the edge of your cut. You'll end up with a little divot into your part itself. So what you want to do is pierce away from your part, lead into the cut line, cut the part, lead out a little bit, and then we'll turn off the water jet. Okay. And the way we add those is we right-click on Lead I/O. You go down to Auto Path, Advanced and Configure. Don't do the quick one. Use Advanced and Configure, because right down here where it says Collision Avoidance Strategies, we want you to use Heads-Up Traverses always. Okay? A traverse is anytime the nozzle is moving from point to point while it's not cutting. Then heads up means that before it moves, it's going to raise up off the material about 1 inch, traverse to the next pierce point, go down to the cutting height, then pierce, and then continue on. And the reason we want all your traverses to be heads up is that while you're cutting, a lot of air goes down into the water, comes bubbling up. The water is very turbulent as you're cutting. Even if you tabbed in all of your parts and cutouts, they can lift up a little bit. Because of all that turbulence, making all the traverses heads up just reduces the possibility that the nozzle will run into any of those pieces or cutouts that are sticking up a little bit. Doesn't completely eliminate that possibility, but it helps reduce it. Now, don't mess with any of the offset controls here unless you really know what you're doing, and then when you're done, put them back to the settings that were there. And then up top here, you need to pick one of the 9 green buttons to specify the start point of your toolpath, and then one of the 9 red buttons to specify the end point of your toolpath. And before you can decide that, you need to know where on your material you're going to cut your part and how you're going to find where that start point is. Because as you can see, you can set your start point to be the center of your part, But then in order to decide whether your part's going to fit, you're going to have to measure out in at least 4 different directions to see if it's going to be an okay place to cut. So normally we're going to pick a corner because it's easier to find those on your material to know that, okay, I can cut below this point and to the right of this point. I'm going to pick the upper left as my start point. Let's just, for fun, pick the lower right as the end point, okay? And you kind of notice here in the preview window that it kind of changes the order that it does everything. And then once you're happy with that, just click on Go. And you'll notice that it turned all the lines of our part purple to represent a cut quality of 3. The dotted green lines are the heads-up traverses, and then the orange lines are the lead-ins and lead-outs. There are actually 5 different cut qualities you can choose. 1 is the lowest, 5 is the highest. And changing the cut quality doesn't change anything as far as the pressure of the water or the flow of the garnet. All it does is for higher cut qualities, the water jet nozzle will follow your tool path slower. That gives the water jet more time to stay straighter so that it doesn't start to bend and wiggle as much at the bottom of the cut. Now, you're free to use whatever cut quality you want on this machine, but be aware, if you use the higher cut qualities, the water jet nozzle will go slower, your cut will take longer, it will use up more garnet, and so then it will cost you more because you pay for usage of the machine based on the estimated time it takes to cut your part. And the way you can change the cut quality is if you right click on select, there's select quality equals. That brings up a menu of all the things that the lines can represent. So there's traverse, heads up traverse, cut qualities 1 through 5, minimum taper, etch, scribe, water only, lead in, and close. So if I were to click on the purple for cut 3, it would turn them yellow. Yellow means it's selected. Select only the cut lines that are cut quality 3. Then down here under quality, I can right click on quality, go up to selected, and now I can click on the 5, changes all the yellow lines to blue to represent a cut quality of 5. And you can even use the shortcut keys. You can do S for selected, Q for quality, hit the number 5, selects all the cut quality 5s, hit Q, S, 3, and we're back to everything being cut quality 3. So one last thing we may want to do to our toolpath is to add some tabs. So like I said, as you're cutting, the water becomes very turbulent, things move around, even things as thick as 1/8 inch aluminum can start to float away in all those bubbles. And anything that falls into this tank is just, you can just consider gone forever. Okay, we're not going to fish anything out of the tank of water. So what we can do is tab your parts, and what that does is it interrupts the cut line so that it leaves whatever you're cutting slightly attached to what you're cutting it from. Okay, and the way we can do that, we can right click on lead IO, go down to create tab, or if you're adding a lot of them, you can do a Control T. If you need to change the options for the tab, there is an options button down there under tab tools. You can change the part side gap, the tip side gap, the length of the tabs themselves. But the one that it defaults to right now works pretty well for most thicknesses of materials that we're using. Control T. Let me zoom in and just tab this internal cutout to the part. Make sure it's facing the direction of your scrap. So because this is a cutout, I'm pointing it towards the cutout itself. If I were to tab the part itself, I would leave it pointing towards the rest of the material or outwards. Okay. I'm going to zoom in here and show you what happens when I actually click the tab into place. What it does is it breaks the cut line so that the cut will come down here, turn towards the scrap side, do a short lead out, turn off the water jet, do a short heads down traverse, pierce again, and then continue on with the cut. It's okay to do a heads down traverse here because this should be all new material that has no possibility of lifting, and this is a very short traverse. Okay. So we've added our tab to this internal cutout, and next we can generate the actual toolpath. And to do that, click on Path, and you'll notice that the cursor now says Pick Start. What we have to do is click near the start point of our toolpath. Now you can actually pick the end point as your start point, and it will do it, but your part will not end up looking like you expect it to, because the first thing it will do is come over here, cut your perimeter out. The part will then come free, probably move a little bit, possibly fall into the tank, and then you will try to do these internal cuts without something holding the part down. They won't be registered, the cuts won't be straight, will not be what you expect. So you just need to click near the start point, and what it does is it generates the toolpath. You need to take a close look at this picture because it really tells you what's going on. If we zoom in, you can see that your cut lines are still there in purple. The white dotted line represents the actual path of the nozzle, and the red represents all the material that's going to be cut away. Okay, so make sure your internal cutouts are being cut on the inside and your part itself is being cut on the outside. You can click on Check for Problems, and it's looking for collisions, it's looking for possibly the offsets being on the wrong side, and it's looking for radii smaller than the offset. Now, if we look at this corner here, it's actually drawn with two straight lines intersecting, and it shows that there's this semi-triangular section here where the material will not be cut away because of the radius of the water jet itself. In order to remove this material, the water jet will have to intrude into your part and cut away some of your part. And because this is drawn with two straight lines, they kind of assume that we understand that. But if you were to actually draw in a radius that's less than the radius of the water jet itself, it will flag that as an error. But then you can choose to just ignore that and go ahead and cut anyway. So everything looks, if anything looks bad, just hit reject. If everything looks okay, click on save. And now what it's done is it's saved a .ord file, which is your actual toolpath. Then you can save this file as a DXF, because when you import it, what it does is it appends _imported _DXF to the file name, and then you can save this as a separate DXF file in case you need to come in and make some changes, like add more tabs or change the cut quality. You can do that on this file. So we've created our toolpath file, our .ord file. Now we can open that in Make to actually cut our part. And as a convenience, you can right-click on Path, go down to Open ORD Path in Make, and it will take that ORD file and open it in OMAX Make. So in here, we should see a preview of the file that we want to cut. Don't mess with any of the controls on this right side unless you are doing something like cutting very brittle material like ceramic or glass. The only thing you really need to mess with is the material type and the thickness. Don't mess with the offset or the scale, or your part will come out the wrong size. So we click the down arrow under materials. You can see that the list of materials that they know about. So there's ceramics, composites, metals, plastics, stone, wood, and a bunch of other materials. But today we're just going to cut boring old aluminum 6061. Right, in 1/8 of an inch thickness. And if you don't find the exact material you want to cut in the list, you just have to pick something that's close to it as far as hardness and cuttability. And once that's all good, just click on OK. It always complains about not being homed in a while. You can go ahead and ignore that because we ignore the user home up here. We only care about zeroing out this path start and the Z height before starting to cut. Should see a preview of your part here. And then over on the right, there is a summary of the water jet cut job. Double check that the material is correct. Double check that the thickness is correct. Because if you err in one direction and say you told it that it's a harder or a thicker material than it really is, you're just going to be wasting time and wasting money. Okay. If you err in the other direction and you told it it was a softer or a thinner material than it really is, you may end up getting a little wet because the water jet may not be able to get all the way through your material, and that high pressured water has to go somewhere. It's probably going to go up and then back down wherever you're standing. So right here where it says estimated time to make that part, for this part it says 1.462 minutes. That's how you're going to know how much this will cost you to make. You're going to take this number of minutes and round it up to the nearest whole number, which is 2, and then have to pay for 2 minutes of OMAX Waterjet cutting in the Jacobs material store. Okay, and currently the price is $1.11 per minute. So just for cutting this part will cost you $2.22, not including the material. And down here, just as a sanity check, you can double check the width of the path and the height of the path to make sure your part is the correct size. Now, if you'll look at the slats in this machine, you'll notice that as the water jet cuts your part, it cuts itself at the same time. So all of these steel slats are being cut, they're sitting in this water, they're getting rustier and rustier. So we have this ever-growing forest of really sharp, rusty pins of steel in here. When you're loading your material in and taking your material and your parts out, you don't want to cut your hands on any of these rusty points and possibly getting tetanus. Also, the water in here only gets drained out maybe once a year. Okay, so it will have been sitting in here for who knows how long and have who knows what growing in it. Okay, so you don't want to cut your hand on any of the steel slats and get any of that nasty water under your skin. All right, so while you are loading your material in or out, wear a pair of gloves. Okay, just going to load in this piece of aluminum. And when we load it in there, we want to make sure it's laying flat on the slats. And you can use this alignment bracket to kind of align the material to the axes of the machine. Okay, make sure it's laying flat. Don't put the material on top of this alignment bracket, or else it won't be laying flat. And you then run the possibility of cutting into the alignment bracket itself. We're going to use these clamps to clamp our material onto the slats. The way they work is this barrel portion has to be in one of these cutouts. Usually it's just this first one. There's a T-nut on the end of the bolt and then a giant nut to tighten it up. And the way it works is you put the T-nut into the slots in the rails. I usually give it a 90-degree turn to make sure the T-nut is locked into the rail, and then just tighten it down. And what you're doing is pushing the material straight down into the slats. Okay. The material is laying flat on the slats, and so we're ready. Next, we need to find our start point and then set the Z height to the proper height for cutting. And what I do is I flip up the cup over the nozzle just so we can see the nozzle, and then set the Z height. So we have this height gauge always hanging on the side of the machine here. This is a piece of steel that's 60 thousandths of an inch thick. So we know that we want the nozzle at least this far away from the top of the material. There are plenty of ways to move the nozzle around on screen, but I really prefer you using the keyboard instead of the mouse, because you need to be watching the nozzle as you're driving it around. If you're doing that and you're not watching the screen, the mouse could slip off of the button, and then you could just click, and then who knows what you're hitting. Harder for your finger to fall off of a button on a keyboard, okay? So you can use the arrow keys, the ones that are by themselves down here, to move the nozzle in the X and Y directions. Moves very slowly, unless you hit the shift key first and then one of the arrow keys, and then moves in a much more reasonable speed. Then with the number lock on, you can use the home or 7 key, move the nozzle up. Use the 1 or the N key to move the nozzle down. Okay. Then I'm going to put the gauge underneath the nozzle, move it down till it just starts to touch it. And then you can switch over to using the page up and page down button, the ones that are by themselves, not the ones that are part of the number keypad. Every time you hit the page down button, it goes down 10/1000ths of an inch. So now we get it till the gauge looks like it's parallel to the material. It's almost pinching right there. We don't want to get it that tight. We usually go up to the first place where it's not pinching and the gauge can move freely under the nozzle, and then usually go up 1 or 2 more. So we're actually closer to 70 or 80 thousandths away from the material. Especially on thinner materials, you want to give it a little more wiggle room because, like I said, water is very turbulent. On thin materials, the material can actually move up and down while cutting is happening, and you don't want to block the nozzle because that high pressure water has to go somewhere. If it can't go out the nozzle, it's going to blow out the garnet tube here and then blow water out of the side. Okay? Once we have our Z height set, we're going to come over here on screen and click the 0 button, which will 0 out our Z height counter. I'm going to move the nozzle into a place, right? Because remember our start point was at the upper left. So I'm going to pick a spot where I know I'm in the upper left of a clear spot on the material. Right there looks good. I'm going to come over here and 0 out the path start. Z0, X and Y0. This is where I want the nozzle to be when I start cutting. Okay, if you don't see those 3 zeros, don't ever start cutting because it will cut in some unknown place. To make sure that this is a good place for me to cut, what you can do is click on Begin Machining, then right click on Start. Don't left click because that's what you would click on to actually start the cut. And because the charge pump's not on, the high pressure pump can't turn on, it's going to throw an error, and then we'll have to clear all that out. Right click on Start. You can go down to Dry Run at Full. What it's going to do is run through your entire tool path as fast as it can. Okay. And then you can watch it as it runs through there and see where the nozzle is actually going to cut and see whether this will fit in the space that you've allowed it. So that looked good. All right, so after it's done the dry run, you can close that window. Make sure you hit the Go Home button to go back to the path start. Another quick way you can check to see if your part is going to fit on the material, you can right click on Begin Machining, go down to Go to Spot on Path, and just pick a spot on the tool path. To say the bottom, this is as far down as it will have to go. Okay, you can close that, do it again. So go to Spot on Path, click over here on the right. This is as far to the right as it will go. Okay, and I just want to check this lower part over here on the left. This is as far to the left as it will go, and it looks like it all will fit. And so this is a good spot for our path start. So I'm going to make sure I go back home. We're almost ready to cut. And usually what I do is run through a checklist that runs physically right to left before starting the cut. Then once the cut is done, I undo everything left to right physically. So starting all the way on the right, we look at the garnet hopper and we make sure we have enough garnet in here. Gives us an estimate of about how much we need. It's saying we need about 0.71 pounds, so there's plenty in here. If you look on the scale here, the second one from the right is pounds. At the bottom it says 5. At the top it says 25. But because the way the garnet drains out of the hopper, it never gets below 7. So that's really your 0. Don't let it get below that, and you can go above the 25. If you need more garnet, we keep it in this container over here. Just put the pitcher under the nozzle at the bottom, lift the handle, and then the garnet should fill the pitcher. Push down on the handle to stop it, and then you can take the pitcher of garnet, lift the top of the hopper, and pour it in there. Okay. Now, if you have any excess garnet left in the pitcher, just pour it back into this container because we don't want it sitting out and possibly getting wet. Also, only fill this when the machine is not running, right? For 2 reasons. One, you're not supposed to be in this area while it's running. Two, we don't want this open while it's running because then there's the possibility of water getting in there, causing the garnet to clump. And if that clump works its way down to the bottom, it may stop the flow of the garnet and then cause the water jet to continue on to try to cut with just water and no garnet. And you may end up getting a little wet because the cut may not go all the way through the material. Okay, so we have enough garnet. We come over here, can flip the cup down on the nozzle. Okay, put the splash guards up. They just hook on the edge of the water tank. Move over here and then raise the level of the water. We want the water to be about an inch above the top of your material. I usually use the clamps as a gauge and just go to the first ridge you see on the clamps, which is right about there. Okay. Then double check in the software that my Z height is 0, the path start is at 0, 0. And then the last thing I do is make sure everybody in the area is wearing their safety glasses. And then you can turn on the charge pump. Okay, come back to the software. I can then click on begin machining, click on start. You should hear the high pressure pump start up. The nozzle will traverse to the first pierce point. You'll hear a clicking sound and then the sound of cutting happening. Okay, so click on start. Hear the high pressure pump turn on. Goes up, heads up traverse, first pierce point, click and cut. And you hear that low kind of growling sound. That's the sound of successful cutting. Now we're done. First thing we want to do is turn off the charge pump and then lower the water. And we can close the OMAX path control box here so that we regain control of the nozzle. I like to just lift it straight up and then to the right, out of the way. And then we can take our part out of there. Okay, take down the splash guard and then use the hose to wash off the excess garnet that's settled onto everything in here. Wash out the rails. And then we can pull our part out of there. So this is our cut part, and you notice that the insert that we tabbed to the part itself is still attached. And to get it out of there, you can just push it a couple of times and just metal fatigue will break that tab right off. Okay, then you'll have to clean off the little tab material there. So make sure when you're tabbing, you put the tabs in a place that's easy to clean up. Okay, you don't want to put it on the inside of a curved surface if you can help it. Just nice flat surfaces are easier to file or sand down. Okay? Once you're done, make sure you remove all of your material and your parts. Careful not to drop anything into the tank. Little cutouts, save those from going in the tank. And then lift your material out and give it a good rinsing off to get rid of any excess garnet or nasty water from the tank. Take it out. Okay. And if you need to dry your parts off using the compressed air, you can do that over this rubber mat. It's fine to do that. That's why it's there. So once you're done with your cut, I usually like to lower the water as much as I can. Make sure you quit out of the software and then place an order in the Jacobs material store for any of the garnet that you used.